Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Darja Orlova is an experienced Flutter developer and Google Developer Expert in Flutter and Dart. She's a Flutterista and organizer of the Flutter Riga meetup. Here she's talking about Backend-as-a-Service for indie developers. Let's dive in.
Hi everyone, my name is Darja and I'm excited to see you at my talk, Backend-as-a-Service, a lifesaver for an indie dev. I've been building apps for more than 8 years now. Most of my career, I've been building apps for clients, in various domains, teams, and tech stacks. But one thing that has always bothered me is that no matter how much time I invest into those projects, they will always be someone else's dream or business. On the other hand, building those apps was a breeze, because I wasn't alone. There was always a client who sponsored the whole thing, and of course designers, project managers, QAs, backend developers, and front-end developers. And my focus was obviously on front-end development. But at the end of last year, I made a career switch and embarked on a journey of indie development. The best part is that now all of those projects belong to me, but it also means that currently all of these wonderful team members are also me. Well, to be fair, also my husband, who is also a developer. So obviously this led to a dilemma: how to balance the limited time, money, and skills without compromising on security, performance, and functionality. Well, if you're at my talk, then you already know the answer, with the help of the already classical duo of Flutter and Firebase. Now, let's dive into the details. Let me introduce you to one of my latest apps, NativePal, a tool that helps you practice foreign language, powered by GPT. The core feature of the application is a chat with a character. For each language, we have a set of characters with different interests and backgrounds, who act as your pen pal. They are AI chatbots and you can text them whenever you want in the free format. And besides practicing a real language, you also get instant feedback on your mistakes and tips how to improve. The bots are implemented with GPT API. GPT offers different models with which you can interact, and the most known ones are GPT-3 and 5 and GPT-4. In order to make a request to the model, you need to specify the prompt, the actual text input of what you want from it, and also specify a role from who this prompt is coming from, a user or the system. The request is measured in what is known as input tokens. Then you obviously sign with an API key and get a response in a similar format where you have a reply and the role in this case is assistant. It is also measured in tokens, which are called output tokens. For my use case, the roles in the request are very important. Since the user can chat with different characters, I need a way to set up those characters. I should be able to give them background, preferences, and explain how to act. This can be done with the help of roles. The system role is the one where you can describe the context for the whole chat. For example, as I did for Señor Gato. You're a cat from Madrid, Spain. Your name is Señor Gato, your favorite food is shrimp, and so on. Then the actual conversation is led by the user themselves, hence the user role, and the replies from the GPT AI have the role of assistant. Here's how an example request could look like. It's a post request to the endpoint chat completions, and in the body we send the name of the model as well as the whole chat history in the field messages, where each message has the content and the role. Another very important concept is, of course, tokens. Tokens are used to measure text, and one token roughly equals to 4 English characters. So, for example, a phrase, "Full Stack Flutter attendees are awesome, so are cats," and some ASCII art is 76 characters and 21 token. The reason why tokens are so important is because you pay for them. For example, using GPT-3 and 5 model will cost you 50 cents for 1 million input tokens and $1.50 for 1 million output tokens. But using GPT-4 model will cost you $30 for 1 million input tokens and $60 for 1 million output tokens, which is way more expensive. So choose and use your model wisely. So tokens equal money. And the API key is what unlocks the access to tokens, hence to your money. So that's the first thing that we will need to keep safe. Before we dive into the details of securing our API key, we first need to get one question out of the way: where to store the data. My assumption is that this isn't the first time you're hearing about Firebase, and because our time is limited, I will focus only on important parts. To store my characters and chat data, I chose Firestore. Firestore is a NoSQL database provided by Firebase. The data is stored in documents as opposed to tables. It has its pros and cons, but it is out of scope of today's talk. We do need to keep in mind, though, that for what I'm going to talk about further, Firestore is the foundation. Now, with that question out of the way, let's answer the next one: how to use GPT API in a secure manner. As we have just learned, our API key gives access to tokens, and tokens are our money, so we really must guard it. We have our Flutter app on the client side and our Firestore database on the server side. One way to use GPT would be by using it on the client via GPT REST API or OpenAI Client SDK. But both of these options mean that the API key is stored on the client side, which is inherently insecure. This is important for all sensitive API keys, and all generative AI API keys are sensitive. So this advice is applicable no matter which provider you use. Also, a good security practice is API key rotation. If we store it on the client side, we would need to release a new app version with force update logic in order to update the key, which leads to a lot of inconveniences. So the question is, how can we shift this to the server side? One way would be by making use of Firebase Extensions. And specifically for our use case, the chatbot with ChatGPT extension made by Shift Escape. Firebase Extensions help you deploy functionality to your app quickly with prepackaged solutions. You can check them out in the Firebase Extensions hub. There are many different ones created by Firebase team, as well as many other companies, such as Stripe. You can do things like translate text, resize uploaded images, send greeting email on new user sign up, and much more. If you want, you can even build one yourself. To understand them better, let's take a look at an example. In order to use an extension, we need to click the install button, and it will lead us to the configuration page. There, we fill in parameters such as prompt, model, collection path, and of course API key. This API key is then stored in Google Cloud Secret Manager and isn't available on the client side. So how this extension works? Users write their messages via Flutter application, and we save them to Firestore. Whenever a new message is saved to Firestore, a cloud function is triggered, which in turn calls the GPT API. The response from GPT API is then written back to Firestore by the same cloud function. And because our app is subscribed to database changes, it gets automatically updated with the response. So we have now unlocked another level, Firebase Extensions. As I have mentioned, they are built on top of cloud functions. But what are they, and why would we need to use them? Well, this specific extension, while it does its job, is not sufficient for my specific use case. You see, I need to be able to set the role, system role for character description, and user role for user messages. Unfortunately, with this extension, it wasn't possible, so I had to find another solution. And this solution is a custom cloud function. Cloud Functions for Firebase is a serverless framework that allows you to deploy small pieces of backend functionality as standalone functions without needing to maintain a custom backend infrastructure. There are two main use cases for Cloud Functions. One is to call function directly from your application, just as you would do with REST API, for example, or a Cloud Function can get triggered in the background as a reaction to some Firebase service, for example, when we write something to Firestore. Once we have written the code for our function, we then deploy them via Firebase CLI. And optionally, if our function is callable, we can call it from our Flutter app. To do that, we use the Cloud Functions package and use it like that by specifying the function name and parameters. The good thing about functions is that they are automatically scalable, as you start to get more calls to your functions, more instances of those functions will be created. But on the other side, if you don't yet have many calls and your function stays idle for too long, they can be killed to not waste resources. This means that the next time they are called, it will be a cold start, which takes a bit more time because it needs to set up resources. One life hack that I've heard about but haven't tried myself yet is that while you don't have many users, you can merge all of your functions into one, and this way it will be called more often and will live longer without requiring a cold start. So let's overview how it works. The user message from the app is written to Firestore via path messages ID. Then the cloud function gets triggered by this write. In turn, the cloud function calls GPT API, and once it gets the response back, it's routed to the same database. The way we use GPT in this function is completely up to us. Our app subscribes to the update, so whenever there are changes in messages path, we get that update and show it accordingly. And here's a piece of function that listens to the message being written to Firestore. As you can see, we have callbacks, such as onDocumentCreated, where we specify the path that interests us, and in the body of the function, we can read various parameters and do whatever we need to do. Cloud functions are very powerful and useful. By delegating logic to the function instead of the app, we make the app completely unaware that GPT API is even used. From the perspective of the app, we just read and write to database. API key is safe and isn't stored on the client. Moreover, we can even swap out GPT for Gemini or any other Gen AI completely remotely without updating the app code and shipping new version. We can even A/B test them. And because cloud functions can have admin rights, we can leverage them and store some data in Firestore, which can then be secured by Firestore security rules. There is a big downside to cloud functions by Firebase at the moment, though. They can't be written in Dart, only in JavaScript, TypeScript, and Python. This is already a meme in the community at this point. But I think it's one of the most upvoted results on Firebase user voice forum, so hopefully one day. Now that we have built our Firebase foundation, let's see if we can add a little extra. Performance monitoring is a valuable tool to track your app performance. You can track many things like app start time, call functions performance, or even custom traces. To start tracking, all you need to do is add the Firebase performance dependency to your Flutter project, and some of that data, like app start time, will be already tracked out of the box. If you want to track some specific actions in your app, this is also very easy to do. You need to create an instance of a trace, give it a name, and then just call start and finish around the code that you want to track. With the help of performance monitoring, as well as feedback from my first users, I found out that often the messages sending function in the chat was taking way too long to complete. Apparently, Signor Gatto could take 10-20 seconds to reply to a short message, which nowadays can be a long time for a human, let alone for an AI chatbot. The culprit turned out to be not Signor Gatto or any other characters. The thing is, for chat message generation, I use GPT-3 and 5 model, which performs pretty well. But beside chat messages for each user message, I also generate an error report via separate request to GPT, and that request uses GPT-4 model because it's much more suitable for that use case. Unfortunately, it is notorious for taking too much time. I'm not sure why, since this is coming from OpenAI and there isn't much I can do about it. But I did make the UX better by asynchronously generating those messages. Now, the character message arrives almost instantly, and the error report is updated a bit later. Previously, I waited for both in order to send the reply to the user. And now, we have one final Firebase function left to unlock. Firebase offers another service that adds an additional layer of security to the Firebase requests. This service is called AppCheck. What it does is it verifies that the request coming from your app is, first of all, coming from your authentic app, for example, signed with your certificate, and second, that it's coming from an authentic, untampered device. It works in the following way. To each request to a supported Firebase service, AppCheck adds a special token. Firebase service then checks if this token is valid. If it is, your request gets fulfilled. If not, it gets rejected. The token is generated and verified with the help of different providers. For example, Play Integrity provider on Android and App-Attest and Device Check providers on iOS. These providers are made by Google and Apple themselves, hence they use their infrastructure and offer valid protection for your request. To make use of AppCheck, you need to register your apps in the Firebase console. Then you need to select the providers and configure each provider. Finally, in your Flutter app, with the help of Firebase AppCheck package, in your main method, activate the relevant providers. My tip is to test your version internally before shipping, that the token really is getting generated correctly. I had an issue when everything was seemingly okay, but on the version from test flight, each request to Firebase was extremely lagging. Turned out, even though I wanted to use only App-Attest because App-Attest is used on iOS 14 Plus without device check, hence I haven't configured it, the AppCheck was still failing to generate token each time, and that's why each request to Firebase was taking so long. When I fixed the configuration, everything worked smoothly. An important thing is that if you haven't enabled AppCheck from the first version of your app, if you enforce it right away, many of your regular users who have not yet updated the app will get their request denied. So what you can do is monitor and wait until the majority of your users have updated. You can check that by the amount of verified and unverified requests in Firebase console. Once they have updated, you can enforce it. Of course, if you notice some suspicious activity before that, you can enforce it right away. So now we have seen how we can secure our app from various angles with the help of Firebase. Let's answer one final question for today. How to handle subscriptions securely. As we have learned, GPT APIs are not free and I pay for each request. Since my app is not a charity app, I of course need to offset this charge to the users via subscription. To manage the subscription flow, I use the RevenueCat SDK, which makes the experience much more smoother and almost plug-and-playable. Setting up in-app purchases, such as subscriptions, can be very painful, especially on multiple platforms, but RevenueCat makes it much easier, and I've been using it for multiple applications. Also, they have absolutely the best swag. Promise you, I'm not sponsored, I just love cats. The thing is, if you only use the RevenueCat SDK on the client and control access to premium features via local flag, such as is premium, no one is stopping malicious actors, especially with Android apps, to repackage it with the flag hard-coded to true and redistributed. So once again, it would be great to delegate this logic to the server. And we can do that with the help of RevenueCat extension for Firebase Store. Whenever a user purchases a subscription, this extension writes the according data to the Firebase Store database. We can then check this data from our cloud functions in order to control access to the premium features from the server side. As with the previous extension example, you need to configure the RevenueCat one with relevant parameters. Technically, if you have added AppCheck, then even by doing just that, it won't be possible to use repackaged APKs, because the Firebase request will get denied. But more layers of security are in general better than less layers of security. Of course, nothing is 100% bulletproof, and malicious actors are always finding ways to break something, but it is in our hands to make it harder for them. In some cases, much harder, and maybe not even worth it. So let's quickly summarize. Always avoid storing sensitive API keys on the client. If there's a suitable Firebase extension, use it. If not, write your own cloud function. In any case, enable AppCheck and control access to premium content on the server. Thank you. If you want to learn more about my journey as an app developer, you can subscribe to my newsletter on Substack. And now it's time for your questions.